Okay, here we go. Your very first video of the year. I know you are super excited. This is section 1.2, algebraic expressions and sets of numbers. The homework was page 14 and 15, 2 through 22, and 32 through 36 even. So I'm doing 1 through 21, 31 through 35 odd. So your first question said, if it says, what is 5x when x is 7? So 5x means 5 times x. So that would mean 5 times 7, and 5 times 7 is 35. Okay? So number 3 says 9.8z when z is 3.1. So same situation. We have 9.8 times 3.1. So 9.8 times 3.1 is 30. Let me try that again. 30.38. Far right? So we have AB when A is 1/2 and B is 3/4. So then we have 1/2 times 3/4. And hopefully you remember, when you multiply fractions, you just multiply straight across. So you have 1/2 times 3/4. So you do 1 times 3 is 3. And 2 times 4 is 8. So you end up with 3/8. That cannot be reduced any further. So your answer is just 3/8. Then we have 3x plus y when x is 6 and y is 4. So we have 3 times x, which is in this case 6, plus y, which in this case is 4. So order of operations says that we do multiplication first. So 3 times 6 is 18 plus 4. 18 plus 4 is 22. And that's all you can do on that one. Alright, the aircraft B-737-400 flies an average speed of 400 miles per hour. The expression 400t gives the distance traveled by the aircraft in t hours. Find the distance traveled by B-737-400 in 5 hours. So we're going to take our 5 hours, that's what t is. We're going to plug it into the equation here, and we're going to figure out the distance traveled in 5 hours. So you have 400t, and they want to know what happens when t equals 5. So then you have 400 times 5. Now 400 times 5 is 2,000. So it'll be 2,000 miles. Okay, number 11 says, employees at Walmart constantly reorganize and reshelve merchandise. In doing so, they calculate floor space needed for displays. The algebraic expression L times W, or you guys know that as length times width, gives the floor space needed in square units for a display that measures length L units and width W units. Calculate the floor space needed for a display whose length is 5.1 feet and whose width is 4 feet. So we have length times width. When length is 5.1 feet and width is 4 feet. So that would be length is 5.1. That's supposed to be times width is 4. So 5.1 times 4 is 20.4. And remember, when you're finding area, it would be feet squared. And that's your answer. Alright, the B-737-400 aircraft cost $2,948 per hour to operate. The algebraic expression 2,948t gives the total cost to operate the aircraft for t hours. Find the total cost to operate the B-737-400 for 3.6 hours. Okay, so again, they give us the formula, 2,948t, and they want to know what happens if t is 3.6. So we're going to say 2,948 times 3.6, and that is 10,612.80. And we're talking dollars here. So in order to operate the aircraft, when you multiply that, you get $10,616.80. So in order to operate the aircraft for 3.6 hours, it costs $10,616.80. So you just multiply those together. Alright, so on numbers 15 through 21, it says, list the elements in each set. Okay, so we're talking about example 3 in the book here. So here they want to know, when you're talking about this little symbol here, what this means is x is the set of numbers such that x is a natural number less than 6. Now, like we talked about in class today, x is, what a natural number is, are your counting numbers. So your counting numbers that are less than 6. So what number do we start our counting numbers with? Well, we start our counting numbers with 1. So 1's less than 6, right? 2 is less than 6. 3 is less than 6. 4 is less than 6. 5 is less than 6. Is 6 less than 6? No. So we're going to say the set of numbers, 1. Oh, holy crap, that was terrible. Alright, let's try that again. There we go. The set of numbers, 1, 2, 3, 4, and 5. And that is the set of numbers, the set of natural numbers less than 6. Alright, now, x is the set of numbers, x is a number such that x is a natural number between 10 and 17. Now remember, natural numbers are our counting numbers. So let's count numbers between 10 and 17. Is 10 between 10 and 17? No. Alright, so let's count between 10 and 17. So let's make our little squiggly. What's the first counting number between 10 and 17? 11. Then 12, 13, 14, 15, 16, and we don't count 17 because it's not between 10 and 17. Here we got x is a whole number that is not a natural number. Okay, our natural numbers are our counting numbers. So let's think about what our whole numbers are. Okay, can you think of any whole numbers that are not our natural numbers? Okay, our natural numbers are all of our counting numbers. Our whole numbers are all of our counting numbers, but what do our whole numbers include that our natural numbers do not? Can you think of anything? Just 0, okay? Now, I shouldn't have done that little squiggly because that'll confuse you guys. So I would just make a normal 0 here. Just 0, okay? Alright, and number 21 says, x is an even whole number less than 9. X is an even whole number less than 9. Okay? So they consider 0 an even number. 2, 4, 6, and 8. Okay? Alright, now, in numbers 31 through 35, they're asking you to look at this set of numbers, and they're asking you to say which of this set of numbers is a whole number, okay? So you're going to look at each one. Is 3 a whole number? Yes, 3 is a whole number. Is 0 a whole number? Yes, 0 is a whole number. Is the square root of 7 a whole number? No, it's not. Is the square root of 36 a whole number? Yes, it is, because the square root of 36 is 6. Is 2/5 a whole number? No, it's not. Is negative 134 a whole number? No, it's not. So that actually finishes our set of whole numbers. Now we're going to look at the same set of numbers, but now we're talking about natural numbers. Now remember, our natural numbers are our counting numbers. So is 3 a counting number? Yes, it is. Is 0 a counting number? No, it's not. Is the square root of 7 a counting number? No, it's not. Is the square root of 36 a counting number? You wouldn't think so, but it is, because the square root of 36 is really just 6. Is 2/5 a counting number? No, it's not. Is negative 134 a counting number? No, it's not. So that that was a really bad one too. So that finishes up our natural numbers. Alright, there we go. Alright, looking at the same set of numbers, now we're talking about our irrational numbers. Is 3 an irrational number? No. Is 0? No. Is the square root of 7? Remember, an irrational number is a number that the decimal goes on and on and on and on forever. So, square root of 7? Yes, that is an irrational number. Okay. Square root of 36? No, that's just 6. That doesn't go on forever. 2/5? Nope. Negative 134? Nope. So just square root of 7 on this one. And that finishes us up. We are done with that homework. So good job, guys. You have finished your first homework assignment with MCR. Hope you guys have a great night.